Hello and welcome to my presentation about polymers used in construction, more specifically polymers used as geotextiles. Geotextile, which literally means the earth protector, is a textile made of polypropylene or polyester polymer, and these materials are particularly important as they can protect buildings from large fault ruptures. They are manufactured in large sheets that can be easily transported to construction sites. Geotextiles embedded in the compacted sand and gravel act as isolator and reduce the impact of large ground deformations due to fault rupture. Geotextile is a planar, permeable, polymeric, synthetic or natural textile material, which may be woven or non-woven, and can be used in contact with soil or rock or any other geotechnical material in civil engineering applications. The woven form of polymers resembles mailbag sacking, uniform size of pores which can vary when subjected to stress under load, which makes them less suited for filtering unclean soils. The non-woven form of polymers resembles felt, created by tangling up fibres into a web mechanically or by heating them up in order to make them bond together. The web is non-uniform. According to the International Union of Pure and Applied Chemistry, or IUPAC, polymers are substances composed of macromolecules, very large molecules with molecular weights ranging from a few thousand to as high as millions of grams or moles. These are made up of repeating units, which are all linked together, and these are known as monomers. The properties of polymers are affected by constituent monomers and by MW, the weight's average molecular weight. This is calculated by the sums of the weights of chains divided by the number of chains. The tacticity of a polymer is defined by which side of the polymer chain the functional groups are present on. The regularity of the macromolecular structure and its specific pattern will influence the degree to which it has a rigid, crystalline long-range order or a flexible, formless long-range disorder. Isotactic and syntactic isomers result in high melting compounds that crystallize readily, which therefore are more suited to becoming geotextiles, whereas atactic sequences produce materials that do not crystallize readily and are low melting. Therefore, an increase in the degree of crystallinity directly correlates to an increase in stiffness and tensile strength, hardness and softening point, and a decrease in permeability. Monomers are added one at a time as a chain grows during chain growth polymerization. The polyethylene layer can be used as a geotextile because of its high density. This means it is suitable to be used as protection and drainage for underground walls and foundations. These reactions occur via free radical chain growth polymerization, where the free radicals are reactive because they possess unpaired valence electrons. Geotextiles were developed in the 1950s to help reduce the rate of erosion in coastal areas. The materials then began to be adapted to other uses, being used in other geological backgrounds to help structure the ground beneath. Lots of places on the planet use geotextiles to strengthen the surrounding area to make a project, such as building roads next to sloping land. The products which are manufactured mainly are geogrids, geotubes and meshes. Geogrids provide stabilization for the ground, geotubes are used for the dewatering of river sediments, and geomeshes are mainly used in landscape applications. They act as reinforcement to help stabilize the land also. The soil is sandwiched between several layers of geotextiles, so the size and construction cost for concrete foundations can be reduced, while buildings can sustain much larger earthquakes without collapse. The geotextile grids are so strong that when you apply pressure, they won't break down. However, they can deform, making it suitable for buildings in earthquake areas. Polypropylene has good tensile qualities, chemical inertness, and a high temperature tolerance, but is sensitive to UV rays. It has a low resistance to creep and minerals. Creep refers to the tendency of a material to slowly deform over a long period of exposure to high levels of stress. Polyester has better creep resistance because it has a higher melting temperature, lower diffusivity, and higher shear strength. It degrades hydraulically, so this could result in flaws such as premature wear and failure of hydraulic machinery. Polyamide is made of nylon 6. The resulting products usually have much greater strength. They are also susceptible to hydrolysis. Polyethylene has an extra strong resistance to tears and punctures and is resistant to UV rays. Polypropylene is one of the most commonly available polymers for non-woven geotextiles. Polypropylene is produced from the polymerization of propylene gas formed during the high thermal cracking of propane and hydrocarbons. High-energy radiation, heat, and catalysts are used to combine the monomers into long molecules, or macromolecules. Polyester is a condensation polymer of a dibasic acid and a dialcohol. The ester group, COO, can be hydrolyzed under certain alkaline conditions. The planar aromatic group is able to stiffen the backbone of the polymer, hence increasing the flexibility of the polymer. Nylon is hygroscopic, meaning that it can absorb and hold onto water. Because it has oxygen atoms incorporated into its structure, nylon has a high affinity for hydrogen bonds, which is why it attracts water from its environment. The amide groups are very polar and can hydrogen bond with each other. So when nylon's oxygen bonds well with the hydrogen in the water, the oxygen present in the water also bonds to the hydrogens in nylon, as it actively draws atmospheric water out of the air. Plasticization occurs when the water molecules bond to the chains of nylon molecules. This means they're more likely to slide over each other at a molecular level. When plasticization occurs in this way, the strength of nylon parts decreases. The geotextile made of polyethylene resin forms radicals which are created due to sunlight. This is not desirable as this speeds up the decomposition process and causes it to become more brittle. Hindered amine light stabilizers, or HALS, are added to prevent radicals from forming due to daylight and UV rays. So that the mesh layers are protected from UV rays, mortar is therefore laid. Weathering leads to the deterioration of the mechanical properties of the geotextiles, which obviously is undesirable when geotextiles are needed to increase the strength of an area whilst retaining their own. The behaviour of the geotextiles is highly dependent on their chemical compositions. Hindered amine light stabilizers enhance their resistance to weathering. Higher amounts of HALS used will therefore result in the best protection against weathering. The photodegradation process involves the generation and reaction of free radicals and can be divided into 4 steps: chain initiation, chain propagation, chain branching, and chain termination. In the initiation step, free radicals are generated. Alkyl radicals are very reactive and can quickly react with oxygen to form peroxy radicals, which is the reason why oxidation is always coupled with photodegradation at ambient conditions. The peroxy radical can then extract a hydrogen from another polymer chain and turn itself into hydroperoxide. The polymer chain that donated the abstracted hydrogen forms a new alkyl radical. This step is chain propagation. Overall, I hope you now know that geotextiles are crucial in construction as they improve and stabilise the ground beneath, as they decrease the process of wind and water erosion. Without a geotextile, the soil will work its way into the base and weaken it. So, thank you very much for your time, and thank you for listening.